All right, guys, let's do this. This is limits number 3, the homework answers. So number 1, since the graph is already given, I'm going to go ahead and just follow the graph, and we want to approach -4, right? And because it doesn't have a plus or minus behind the -4 as a power, we're going to go ahead and try it from both sides. So -4 is all the way over here. So, if this function had gone like this, oops, and all the way up there, so as I approach -4, I would be like, well, I need to go to -4 from the right hand side. So -4 is probably about right there, and then from the left hand side it's probably about right there. So whatever that number is right there, whatever the y value is, because that's where -4 hits the graph, right? So I need that, but I'm using the graph and I can't tell because the graph doesn't go up that high, so I cannot utilize graphing technique. So what else can I do? Okay, so even though there's a graph, I can't utilize the graphing technique. So I can also try substitution. So plug -4 in there. So this is going to give me -4 squared, then -3. Okay, and -4 squared is 16 minus 3. That gives me a final answer of 13. And if you think about it, as you get to -4, what's going to be way up there when the graph hits? And it looks like, yeah, it's about 13 is fine. It's going to be a pretty big number. It's going to be way above 4 for sure. So I'm okay with 13. Right, this one again. So it already has a graph. I'm going to go ahead and use a graph, and in this one we want to approach 2, and again from the right, left. So as I'm approaching 2, so 2 is right here. Okay, so as I'm approaching from the left, as I get very close to 2, right there, it's going to point to that spot. And as I get very close to 2 from the right hand side, that spot, and they both point to that number, which is 12. So on this one, I'm utilizing the graph, and it actually just tells me the answer is 12. Right. This next one, that's what the graph looks like, and it says that I am approaching -2. So -2 is right here. So here's -2. Right, so as I come in from the left-hand side, as I approach -2, my answer is going to be -1. And from the right-hand side, as I approach -2, my answer is going to be +1. And because those answers do not match from the left, does not match the right, I'm going to say the limit does not exist. All right. Number 4. Okay. It says that when x approaches 1. So 1's about right here. Not sure if it will hit it or if it'll hit it earlier, but you know what? So graphing, I cannot tell from looking at the graph. Okay. How about if I plug it in? So how about if I just plug 1 in for x? Because this does say x is approaching 1, so which means that x is getting close to 1, and we can actually just plug it in. So if I plug it in, I will get 1 over 1 minus 1, which is equal to 1 over 0, which is undefined. Right? So I can't figure out on the graph, and I can't figure it out by using my my plug it in. So I can use a table, but in both these cases, you probably already know what the answer is. Right? So as I approach 1, okay, so let's just look at the graph again. So as I approach 1 from the right, it's going to keep going up and up and up and up. Okay, very, very high up to infinity. And as I approach 1 from the left, it's going to keep going down and down and down and down and down, very far down to negative infinity. So in this case, it doesn't actually match anyways. Right? So the limit from the left does not match the limit from the right, because the limit from the left is negative infinity. The limit from the right is positive infinity. So that means that it doesn't match, and we can say that the limit does not exist. And I'm okay with this because I've done it 2 different ways, and it does not give me a single number. All right. So number 5. So I'm going to go ahead and, because I don't have a graph, so I'm not going to utilize the graph unless I have to. But I'm going to go ahead and take that 0 and plug it in where the x is. Okay, let's see what happens there. So number 5, we have 5 over 2 plus e to the 1/2 times 0, which actually makes 0. Okay, and that's equal to 5 over 2 plus, and e to the 0, if you don't know it, use a calculator. E to the 0 power is 1. So that makes 1. So your answer should be 5 over 3, and that's my final answer, 5/3. Okay. 6. I'm going to try the same thing again. I'm going to take that 0, and I'm going to put it in place of x, because that's what it says. Put it right there, right there. And if you notice, it actually is not going to work, right? Because by putting 0 in there, so number 6, right, if I put 0, I'm going to get e to the 0 minus 1, and I'm going to get 0 on the bottom. And e to the 0 is 1 minus 1, okay, over 0, and we get 0 divided by 0. And you know that if we do that, we're going to get a divided by 0 error. So we cannot substitute like how we did number 1. So how are we going to get at the answer then? Well, we only got 2 options left. We either have to look at what happens on the graph, and then with that, we can also look at what happens on the table. So I'm going to go ahead and graph the number 6. So I'm going to graph that, and I'm going to put in parentheses. So e to the x, close that, then minus 1. Close that parentheses also, and then divided by x. I don't need parentheses for the x because it's only one term. Okay, and I'm going to go ahead and zoom in 6 to reset my graph. And let's see what it looks like. So just by looking at this, looks like there is a value there. So when x approaches 0, okay, when x approaches 0, that means that I want to find out what happens at 0. And again, I can't plug it in because it doesn't give me a value. But if I look here at x, here's x. You see my little cursor. Here's x, and at 0, it looks like it's going to be 1. Okay, so it looks like it's going to be 1. I'm not quite sure because I could be a little off. So I'm going to go ahead and utilize my table. So I'm going to go second graph for table. Oh, I need to change that. So second table setting. Change to ask. Okay. So again, if I put in 0, I'll get error. But I'm not going to put in 0. I'm going to put in numbers close to 0, like 0.1, 0.01, and 0.001. You can see that my y's are all looking like 1. Okay, and if I do it from the left side, negative 0.01, negative 0.001, you can see that they're all coming up from the 99-cent side. And then if I go come in from the right hand side, they come in from the $1.01 side, right? So I know now that my limit is going to be 1. Okay, this one again, number 7. If I plug in a 0, I'll get cosine of 1 over 0, and we know that we can't do that. So we obviously can't do cosine of 1 over 0. So we're gonna have to go either look at the graph or a table. So that's cosine of 1 divided by x. And I'm just gonna go ahead and look at the graph. All right, and I'm gonna go ahead and zoom in just so you can see what's happening. Yeah, so this one actually just oscillates back and forth. I'm gonna zoom in some more. You'll see it. It's gonna go up, down, up, down, up, down. Right. So the more I go, the closer I get to 0, the more it kind of goes back and forth. I'm gonna go. You'll see it going back and forth so many times. All right. So there's 0 right in the middle there. You see that it doesn't actually tell me exactly where it's at. Oh. So I won't be able to tell from the graph. And I mean, I might have an idea, but I won't be able to tell, right? And I can't plug in 0 because that will give me an undefined. So I'm just going to go ahead and say, you know what, this right here, it's going to be no limit, or the limit doesn't exist because it's going to oscillate back and forth. Okay, if I go on the table, I'll get the same exact values. It'll get some numbers above and some numbers below, some numbers above and below, because it's going to oscillate. It's going to go back and forth, back and forth. All right, so this one, from each side, your limit is going to be, back and forth, back and forth. So I'm going to go ahead and say the limit does not exist. Okay, 8. I'm going to go ahead and plug in because that's the easiest thing to do, is put a 1 for x. So if I do that, I will actually get, for number 8, sine of pi times 1, which pi times 1 is just pi. So you get sine of pi, and we know from our unit circle that the sine of pi is 0. But if you don't know that, you can always put it into your calculator. Sine of pi, and that gets you 0. So this answer is just 0, because that's what the sine of pi is, 0. Okay, this one I'm going to go ahead and try plugging it in. So I'm going to put 3 in the x, and you can see that it's going to be 7 divided by 0, because 3 minus 3 is 0, okay, which is not going to work. Okay, so that means that I cannot plug it in, and I have to do it a different way. Okay, so I'm going to go ahead and graph it, and then maybe I can do a table of it. So 7, and I don't need to put parentheses around the 7, divided by, but the x minus 3, I need to put parentheses around the x minus 3. Okay, I'm going to go ahead and graph that. So let's see what happens. Okay, and it looks like as I approach 3, 1, 2, 3, looks like it's going to go down from the left and it's going to go up from the right. So my hunch is that it's going to be doesn't exist, because as I go down, it's going to be negative infinity, and as I follow it from the right and go up, it's going to go positive infinity. So this one, my graph actually tells me the answer is the limit does not exist. Okay, and the last one, if I plug in, so I'm going to use substitution method, I'm plugging negative 1 for x. Right there. So this is actually going to make, number 10, ln of 7 minus negative 1, which is really ln of 7 plus 1, which is really ln of 8. And natural log of 8 on the home screen, natural log of 8 is going to be a number. Okay, 2.709. Okay, 2.079, excuse me. And then there's a bunch of other numbers, but that's where I'm going to go with. That's my limit. Okay, if I graph it, actually let's do that. You'll see it. So if I graph it, that's a ln of 7 minus x. Okay, so if I graph it, can't really tell. It's a little weird, but as I approach negative 1, so you think about it, negative 1 right there, you see my little cursor is right here. So as I approach negative 1, it's going to be in that area. Okay, it looks roughly 2. Okay. But because I can't really tell, I'm going to go ahead and do a graph, or sorry, a table. And I'm putting in numbers close to negative 1. So what's close to negative 1? Negative 0.9, right? From the right-hand side. You see how it's 2.0669? What's even closer? Negative 0.99. Negative 0.999. You can see that I'm getting 2.079 already. Okay, that's from the right-hand side. From the left-hand side, it's going to be a little bit over negative 1. So negative 1.1. Negative 1.01. You can see it's the same numbers. Negative 1.001. Right? And then it's basically, you can see the trend.